So today, we'll continue the yesterday's discussion on classes. Okay, you're able to see my screen, right? So yesterday we have covered. Let me uh, take you brief you through the things which we have covered yesterday. So we have seen what is OOPS and why it's useful and advantages, and we have just seen principles of the OOPS and what are the classes and what are the instances of the class and what are the objects and how to create a class and what is init method and why we use it, and we also covered what is self keyword and what's the use of self keyword. Okay, so now we'll start with the str method. Okay, similar to init method, str method is also reserved method in Python. Okay, so what str method will do is it will define how class should be presented as a string. So when we take, let me open collab here. We have this collab here, right? Let's say I have one class with me. Let's say this is my simple class. When I do this p is equal to Python. So I'm just initializing this class, and when I print p here, okay, I think it's taking some default names. Let me make it none for now. You see, it's giving us main Python object at some memory location. So this is how a Python will present as an object. Okay, object or class. Okay, let me do now. So I have defined an str method here, okay, and let me pass some names over here, which will be Mahesh and 28. Okay, if I do print now, if you can see that it is printing I am Mahesh and my age is 28. Okay, you can see clearly, right? This showing I am Mahesh and it's at 28. So I think here it shouldn't be this way. The reason being the print this what you say str method will be automatically invoked by any formatting or print functions. Okay, so current let's see, I haven't given any print. I'm just returning this string here, and if I do some print and if I am commenting it out and if I am printing this, you just give me the Python object at some memory location where it is present. So using str method, we can define how this class can be represented in a human readable format. For now, this is kind of, let's say, since I have taken name and age, I can make it as person. This is my class person, and within person, I can give this name and age. Okay, and let me rerun this now. By looking at the class name, you can infer that this is a class person, like object is represents a person. This object is representing a person, and accordingly I have defined my str class, and whenever I'm printing this, since this p is initialized using the Mahesh and 28. Okay, this p is an instance of this person class with name Mahesh and age 28. And when I print P, it will just give me my name. I am Mahesh and days is 28. If I'm just giving P here, it will again give this. Okay, this str will be invoked only by print or format functions. Okay, print and format are the functions which are used for like displaying output, right? Formatted output to user. So when we use only print and format, this str will be called. Okay, you can see here. I have given class GFG and I have given name and company, and I am returning. I am name and I work for this. When I just access my object, it will give me this output. Clear? And when I am accessing this print using print or format here, it will give me this I am Ram and I work for Google. This object, like class or instance of this class, just show them this in this format. Okay. So why it is useful? Like this is how useful in logging. Okay, whenever we are defining some logging, we need to know what is this class and what is this object. Okay, what is this object about? In that case, we can just have this. Okay, whenever we are printing something, it will print us the information in a way that will be useful for us. Okay, because we'll be checking logs for some useful information. If I'm just printing this particular thing here, there is like it won't give anything for me. Like, so this is my example. So I can also do here, like based on the inputs, like I can do, this is the instance of a class with inputs RAM and Google. Now it will make sense that I can understand, okay, this is the instance of GFG class and RAM and Google are passed as inputs. So I'm logging this information using this print method or format method, okay? As I said, this will be called by print str or format. Okay, you can also use str method here because str will convert everything into string, right? Str will also give us the same input. Okay, this will be only accessible by these three methods. Okay, when we call these methods on our instance, the str method will be automatically called. Okay, if you see here, to just to recollect, I have told you that self will indicate that this method or this class or this variable, sorry, this method or this variable belongs to you. Okay, this is my class and this is my instance. So whenever I'm creating instance, the self keyword lets this instance know that these two variables are accessible by you. These two belongs to you. You can do anything on that. You can make changes using some methods. You can do anything on that. Okay. So this is the use of self keyword. I have defined in init, I have given self and I'm giving name and days. The reason I'm giving this is if we need to pass some input over here, we need to define them in the init. Only then it will accept some arguments class. If I'm not giving this, then I can set it here. Okay, self name is equal to Mahesh and self age is equal to 28. But this will be same for each and every instance which we are creating because we won't be able to pass any arguments to this, right? But, even though we won't be able to pass arguments, we can kind of make changes to that. The reason being this belongs to the particular instance, not class, and we can make any sort of changes on that. Okay, clear with str method, right? And then methods. Okay, just this class methods, I have just given it for our understanding purpose. When I say methods, that's automatically an instance method. Okay, from now on. The reason why I'm telling this, you will come to know. Okay, as I said, always declare self in class methods. You have to give self in methods. Okay, whichever method we are defining, self is the must for any each and every method inside a class. Okay. Now, if you see here, I have defined a product and I have initialized it with the name, types, and price. And I am kind of making indicating that those are kind of instance variables. Okay. And then info. Info is one method. Okay. In my class, info is not taking any input. It is self. Again, this self indicates this info will belongs to the instance of the class. Wherever we are creating instance, this info belongs to that instance. Okay, and it is returning product name is self dot name and belongs to self dot category. Okay, It's just giving a message that product name is this and it belongs to this category and define price in INR. Okay. Let's say we are giving price in US dollars, but in my method, I wanted to print it in INR, okay, Indian rupees. Here I'm giving price in INR is self dot price into 82.22, which is kind of dollar conversion rate. Okay. So let me open this now. Instead of typing, let me copy this as a whole. Okay, if you see, I have defined this class right now. I have this class. So I am initializing product one, and my product one here will be instance of this product class, and name will be iPhone 13. Okay, and its type will be iOS mobile, and its price in US dollars will be some, let's say, 1500. Okay, it's some $1,500. Okay, now I have created instance of my product class. Okay, now I can access any variables from this prod one dot name. Okay, if I give this prod one dot name, it will give me iPhone 13. If I give prod one dot price, it will give me 1500. Because this 1500 it now belongs to this instance. Okay, even though here it is zero, when we are creating instance of this product class, we have passed it 1500 as a price. So product one will be tagged to this 1500 price. Okay. Okay, now I'm just accessing my method prod one dot info, and I need to call this. Okay, remember functions, these are nothing but functions. Functions, when they come inside class, they'll be methods. Okay, functions will always be, should always be called in order to execute. Okay, only then they'll be executed. Okay, you see here product dot info, product name is iPhone 13 and it belongs to iOS mobile category. Okay, now I can also do here product one, and I wanted to check what will be my price in INR. Okay, what will be my price in INR? It will show price in INR is 1,23,330 rupees. Okay, this is how we'll be defining methods. Just remember, methods are nothing but functions which we are defining inside class. Okay, and within class, what we are doing again here, we are just defining this self. Self indicates this belongs to the instance. Whenever we are creating instance, this the instance completely owns this function. Okay, and that's the reason we are giving self keyword here. Whatever arguments we are supposed to take, we can take them here itself. Okay, and we can just use them here. Whenever we are initializing our instance, we are kind of creating this like we are defining these instance variables. So this is method which is nothing but instance method. Okay, this will be tied to the instances. Okay, and then we have getter and setter methods. Okay, as I said, we can make changes to the instance variables. Okay, even though we have created some these variables when during initialization, like we're defining class, whenever we create an instance, within that instance we can make changes to the variables. Okay, let's practically see that. I have my class programmer, and within this class I have this self dot name, self dot salary, uh, self dot technologies, and now I wanted you guys to guess what will be the output of this. Okay, I think I have missed some. Yeah, okay. Okay, now I have this class programmer. Okay, now I am defining prog1 is equal to programmer. Okay, and defining prog1 is equal to programmer. Okay, now what will happen when I do this? Prog1 dot set name. Okay, what happens when I execute this function? Can you guys guess? I have created instance of this programmer class, right? This is my programmer class, and I am creating an instance of programmer class which is prog1. And I'm doing this prog1 dot set name. Is that right? Can you guys guess what will be the output? Okay, so let's try it out. You can see programmer dot set name is missing one required positional argument, which is name. Okay, here I don't have any init method. Okay, I don't have any init method here, and I have just defined this created instance of this class. Within this class, I don't have any like I now have this self dot name, self comma name, and I'm doing self dot name is equal to name. So here I'm kind of setting this variable for this instance. Okay. So if I do this set name without any variable here, it won't do anything. I can just give set name of Mahesh. Okay. And it will be setting the name now. Now if I access this prog1 dot name, be able to see Mahesh. Okay. If I try to access same, which is prog1 dot salary, you can see programmer object has no attribute salary. The reason being here I haven't defined init function. I am not initializing any variables. Maybe instance variable or it may be class variable. I am not initializing any variables here. Okay. I have just these methods. These set methods will set the variables, and these get methods will get the variables. Means it will take like will fetch the variables using these methods. Okay. Now I can do same thing. Prog1 dot set salary, and I'm giving some 20,000 rupees. Okay. And I'm giving same thing again. Prog1 dot set technologies, and I'm giving some list to this. Okay. Okay. Prog1, right? Sorry. And my technologies are, I'm just giving some random technology stack. These are my technologies. Okay. Now I have this prog1 dot name, salary, and technologies. Okay. I can also get them using this. Okay. If I do prog1 dot get name, I'll get output of Mahesh. Okay. If I do prog1 dot get salary, I'll be getting the salary which I have given, which is 20,000. And prog1 dot get text will provide me the technology stack for me. So now you can see this prog1 instance I have created, and there are no variables in this. Okay. After creating, I am kind of using this setter methods to set the variables. Okay. Clear, right? I am passing the variables on the go, and I am creating these instance variables, and this will be tagged to this. Clear, right? So when class is defined, we don't have any name, salary, or technologies. Even after creating instance, we don't have any name, salary, or technologies. These variables. Only after me calling these methods and passing the respective arguments here, it has created these variables, and these variables are tied to this prog1 instance. Okay. Now let's say I do prog2 is equal to programmer again. Okay. Now in prog2, if I try to access names, So display error saying programmer object has no attribute name. The reason being, this will be tagged only to this instance. This is an instance and this is an class. And these are kind of belongs to this instance. Whichever instance we are creating, this belongs to that particular instance. Okay. So this will be this is how we can set or get variables. Okay, from class. And then we have static fields or class level fields. So till now we have seen some variables, like we can do them through init method or we can kind of define setter and getter methods. Clear, right? So we can also have this static or class level variables or fields. Okay, this will be common across each and every instance. Okay, each and every instance, whenever we are creating in that instance, this class like class variables will be shared across all instances. They'll be available for all instances. Okay, so if you see the example here, this class student. Okay, and within this I have defined stream as ECE. Okay, this is my student class, and this student class I am constructing this for my branch alone, and my branch is ECE here, and it should be common for each and every student whom I am kind of creating instances. So not the instance object. Just remember this is my class, and instance will be when I am creating some instance by calling this class object. Okay. When I call this class object using some student and parenthesis, this will create my instance. Clear, right? So if you see here, this now belongs to my class, and I have defined my init method, and within init method I have name and email, and self.name is equal to name and self.email is email. So I'm declaring this as instance variables. This belongs to the instance. Okay, and this is my instance one, which is A. This is my instance two, which is B. And A contains Ram and his email, B contains Sita and his email. Okay, now let's me go to this function. So now I have my student class, and I have two instances of the student class, which are A and B. And A is an instance for student Ram, and B is an instance of student Sita. Okay. Now if I print A dot name, comma A dot email, comma A dot stream. You can see ram at gmail.com and ECE. You can observe ECE I haven't initialized anywhere, but it's automatically tied to this thing. What do you say? This instance, which is A. Whenever I'm initializing this using this student class, this will be automatically tagged. Okay, to each and every instance. Even B will contain same thing. Okay, B will contain B dot name, B dot email, comma B dot stream. So it will contain Sita, her email and brand, stream. Okay, which is my ECE. So clear, right? How class variables will work? Static or class variables. We will define them as static or class variables, and this will be common across all instances. This will be shared across all instances. Even we can get 1,000 different students. The stream will remain same for each and every student. Okay. Now, now we have this. we have seen methods, right? We have seen methods, but here we have three types of methods within class. Okay. So far, the method which we have seen is instance method. Okay. Those are tagged to the instance. Whichever instance we are creating, those will be kind of tagged to that instance of the class. Okay, not the class itself. Okay. Our very first here is instance method. As I said, these will be tied to the instance of the class, not the class. Okay. Whichever instance we are creating, all the methods will be tagged to that instance of the class. Okay. This will take self parameter. So for all the instance methods, self is must. Okay. We have to give self. Without giving self, we can't define any instance method. Let me open this now. And we have this, let's I'm just recopying it here. And if I do this without any self, okay, I haven't given any self over there, and I'm just defining that, and I'm initializing my p is equal to product, and its name will be price will be some $560. Okay, so now if I execute p dot price in INR, it will give me output, which is 46,043 rupees. Okay. Now, if I try to access p dot info here, you can see product info takes zero positional arguments, but one given. Okay. The reason being, I haven't declared it as uh, instance method. Okay. I have just defined it. I haven't passed any sort of these things to this. Okay. So for each and every instance method which we are giving, we need to kind of pass self. Okay. You see here, this is now tagged to this product class, not to the instance. P is our instance. This is product. So now it's kind of not tagged to any instance. Okay. We're not tagging it to any instance, but if you can see here, I'm making use of the self keyword. But I don't have this in my instance. Okay. If I remove these things here and if I try to perform the same thing again, I'll get error saying that name and types are not defined. Okay. The reason being, it's kind of whenever we are not defining it as specifically as class or static method, it will always expect this self keyword. Okay. Only when we are giving self, this will be kind of converted to instance. Okay. It will indicate that this is an instance method. Okay. This error, if you come to this error, product info takes zero positional argument, but one was given. Okay, I'll show why it's giving you. Okay, how we can get away with this. Okay, now if I do the same here, let's say I have this. This is my decorator. Just what do you say? Ignore like what exactly does do. Just take it as a decorator. Okay, or else I'll make it some other decorator. You can see name is not defined, and this you can see this name is not defined. Okay, even if I'm giving here self dot name and self dot type, okay, I won't be able to access anything. Okay, I won't be, it will show me self is not defined. Okay, if I try to access it, let me do one thing here. Let me give some default name. Okay, so now I have given it in some little bit different way. Okay, just given it in different way. Even you can see this default name is not defined now. Okay, I'll tell the reason why what's happening here and why it's kind of are not giving us any input. Okay, but if I give it here, okay, now I'm giving this default name and info, and I'm giving this. Okay, I need to reinitialize this. Sorry, my bad. You can see product name is MacBook and it belongs to laptop category. Okay, I'll explain why what's happening here. Okay, just remember I have just decorated it. Okay. So coming to this, through self parameter, instance methods freely access the method and attributes of the object. Okay. Whenever we have this self parameter with us, so this indicates that this is completely belongs to you. Okay, this completely belongs to you, and you can use each and every attribute of that instance. Okay, whichever is tied to that instance, you can do this. This can also modify object state. Okay, so we have seen this setter and getter methods, where we are kind of after creating instance, we are kind of modified some things like initially we don't have any name. Later on we changed the name. Okay. So if we see this now, let's say I have this same product class and product class, I'm defining it with Samsung Android and this thing, right? Now, when I say p dot name, I print p dot name, I'll get Samsung, right? Now let's say I'm giving p dot name is equal to Nokia. Now if I execute p dot name again, you can see it will now be Nokia. Okay. Initially it is Samsung. So later on I made this p dot name is equal to Nokia. So it will automatically update this self dot name from Samsung to Nokia. So we are kind of actually making changes to the state of the class. Okay. State of the sorry instance. Okay. Class instance. So this can modify object state as I have shown just now. Okay. Instant methods can also access the class itself. Okay. So we have class with us, right? So there we can kind of access a class itself. If I say I have this one more method here, which is define print class. This is my instance method, right? And here what I am doing, I am just printing. So this print class is my this thing, and I'm just doing printing this. Okay, if I do bp dot print class now here, and I call p dot print class, you can see it will print the class. This is my product class. Okay, this instance belongs to this product class, and it is able to access this. Okay, so now here I can kind of make changes to the class variables. Okay, now this default name, when I say this default name, okay, let me print the p dot default name, and my p dot default name here is del vostro. Okay, and you know that this is a class variable, not an instance variable. This belongs to the class. Okay, not instance. So now let's say here within this print class, what I am doing, self dot class dot. Okay, I'm doing this thing, self dot class dot default name. This is my default like class variable, not instance variable. Okay. Now if I initialize the class again, and if I print the default name now, you can see it's del Vosto, right? And I have did this print class. Okay, I just call this print class. Now if I print this default name again, you can see now it became Acer Predator. Okay, the reason being this instance of the class can also access this class itself. Okay, and it can make changes to the class itself. Not only the instance, it can kind of make changes to the class itself. Okay, now this is my class variable, but I have kind of modified it from this instance. Okay, when I have in this pre.print class, it's kind of modifying my class state, and now this default name will become Acer Predator. Okay, if I do this product dot default name, you can see now this is Acer Predator. Okay, this is my class. Product is my class. Even though my class default name is Del Ostro, when I have executed this method, from this instance P, it has made changes to the whole class. Now this default name became Acer Predator. And if I check product dot default name now this is Acer Predator. Okay. If I check this product dot default type here, this will remain same, which is laptop. So I can also update this as well from instance. Okay. Clear, right? I have made change from this instance of the class to the class itself. Okay. So instance methods can modify the class state as well. Not only instance state, it can modify class state as well. Okay. And then we have class methods. Okay. These class methods are tied to the class. Okay, not instance. This will be tagged to the class and it will be available across each and every instance as a common method. Okay. You see, we'll be using decorator. Okay, we'll use decorator at class method. When we use this decorator at class method, this is inbuilt decorator for Python. This will indicate, okay, this is class method. This is not instance method. This is class method. I should treat it as a class method. Okay. So what exactly class method is? This instance method will take self parameter, right? Self parameter. But class methods will take CLS parameter. CLS is nothing but class. So this class methods will take CLS, and CLS defines you belong to the class itself, not any instance. Whatever instance we are creating will be available like commonly across each and every instance. Okay, we take this class parameter that points to the class and not the object instance. Just remember, class methods are tagged to the class, instance methods are tagged to the instance. Okay. And if you say class methods can modify the class state. Okay, they can modify the class state, but they can't modify the instance state. The reason being, the instance will take self parameter. Okay, instance methods and instance variables have self parameter, and whenever we are creating an instance, it's kind of tagged to that instance. Okay, now class won't be able to, this class method won't be able to do anything on that instance method. Okay, the reason being this class is a method tied to the class. But when after creating instance, like this class method has already been utilized over there. We can't make any changes using class method to the instance method. However, they can modify the class state. Okay. The reason being, when I say they modify the class state, let's say I have made some changes to my product class. So that will be applicable for each and every instance which we are creating using that class. Okay. So all class instances share the class method. As I said, this whichever instance we are creating from this class, this class method will be shared across them. You have seen this class variables, right? Class variables are static variables where the stream is shared across all instances. This is same. This class method kind of will be used for it will be shared across each and every instance. Okay. For example, let's say we have a class for database connection. Okay, we have a class for database connection, and using that database connection, we'll be connecting to different databases. Okay, we'll be connecting to different databases or different tables. Let's say different tables. Okay, but all of them will be sharing a default connection string. This connection string is something which we'll be using for making connection to the servers or cloud servers. Okay. So this connection string will remain same for each and every database which we have hosted in our system. Okay. So in this case, we need to pass this connection string as a common thing for each and every this thing. Okay, this connection string as a common for each and everything. So in this case, what we can do, we can have a class method which will form that connection string and it will share it with each and every instance of the class. Okay. So when we define that class, this class method will kind of construct the connection string, which we'll be using for connecting to the databases. Okay. And this connection string will be kind of will remain common for each and every instance which we are creating from this. Okay. And you can let's say we have one data pre-processing step. Okay, so data pre-processing is nothing but we'll be having some model with us. In machine learning terms, we have some machine learning model, and we need to pass some data to the model in order to train the model. Okay, so for training the model, we'll be passing data. So we can't pass data as is. Okay, even if we take databases, let's say from one website, we are collecting some information. We won't be able to store the information as is, right? We need to process it. We need to bring it into proper structure, and then we'll be storing it in the database. So for doing this, whichever information we are taking and whichever wherever we are storing this pre-processing will remain same, right? This pre-processing will remain same for each and every instance which we are doing, right? So we can make this pre-processing a class method, so that whenever we are creating an instance, we can just will do some steps using the instance, okay, which we have created from the class. Okay. So instance methods will be tagged to the instance and class methods will be tagged to the class. Okay, clear, right? Instance methods will be able to modify the class state as well as the instance state. But class methods won't be able to do that. Class methods can modify the class state only, not instance state. Okay. So, and then we have one more method which is static method. So I have shown you just now, right, with this decorator, static method decorator. So this static method won't take self or class or any sort of parameters. Okay, that is just a normal function. Okay, static methods can't modify instance or class state. They can't modify instance or class states. Okay, they can't do anything to the instance or class states. Okay, and it's kind of completely isolated from the class object. It don't have any relation to with the class object. It is just present in the class. The reason being, it makes sense when it is present in the class. Okay. Only reason why we use static method inside class is, let's say we have one object. Let's say we have this person object. Okay. In this person object, let's say we have this walk method. So, or else, let's say we have this details method. Okay, what details method will do? It will kind of just print some details. Hey, I am a person class. Okay, I am a person, and I am initialized from this class. We'll just print that. Okay, and we are just printing that. So we are not using. So this static method, what it is static method here is, it is kind of don't have access to any of the class methods or class attributes. This is just present in the class for the sake being. Okay. And what's the exact use of static method is, we can use it for utility functions. Okay, let's say we have defined this class which will take some arguments, but we need some function which don't require any of the arguments or any of the methods which are in class. Okay, we need to just perform some small utility task which is kind of completely independent of the class attributes and methods. Okay, in that case we can make use of static method. The reason being, we can perform our utility task, whichever we are trying to do, we can perform that task, but this class, this will be completely isolated from the class. Now this will be completely separated from the class, just that it is present in the class. Okay, it will be just present in the class. It won't be able to access any of these things. Okay, won't be able to access any class method, or it won't be able to access any these things. Okay, and but it can since it is present in the class, if you can see my class dot class method, we can kind of access this in this way, but it won't be able to update anything. Okay, as I said, it won't be able to modify the state of the class. Okay, won't be able to modify state of the class. And let's say I have this class method. Okay, when I'm kind of here, I'm kind of this arg I, which is my class variable, and I'm making changes to this class variable. So I'm trying to access this class variable. If I try to do same thing inside this, I won't be able to do this. Okay. So let me practically show you. So now I have C1 is equal to my class. Okay. C1 is equal to my class, and when I say C1 dot R guy, you can see this R guy, which is Mahesh. Okay. As you know, static fields will be tagged to each and every instance. Okay. Class variable will be available, accessible across each and every instance. Okay. When I say C1 dot method here, I'm kind of sorry, I need to call this. My bad. I'm calling, if you can see, instance method is called, and within this, as I said, instance method will be able to access the class as well using this underscore class, which is kind of this is kind of private, like notation for private variables and private methods. So I will see them when we are explaining this encapsulation concepts. I'll show how we can kind of protect our methods and variables. Okay. And when I print C1 dot class method, it will just print class method call. And here I'm just calling CLS, not any self dot CLS. Okay. Here I'm directly accessing my class. Here through the instance, I have taken the instance and I'm checking from which class I have created this instance. And I'm trying to access this. But in this case, you can see I'm directly kind of accessing CLS. CLS is nothing but my class. Okay. And the CLS argay is my this thing. Okay. Mahesh. And it's printing that Mahesh. And you can see CLS is nothing but my main dot my class. Okay. This is my class method. And when I say static method, you can see here again, I have called class method inside this static method. Okay. If you observe here, I'm kind of using this my class itself. Okay. If you see here, this my class is nothing but my class name. This my class is nothing but my class name. Okay. Within this my class, I'm kind of calling this using this. Since this is present, this will be able to access the whole class as is. Okay. But we won't be able to modify or modify any class or instance states. Okay. And see it has called static method called here. Okay. Since this is the call which we have made for this class method, and it is just returning me static method. So this is kind of just present inside my class. It won't take any self, or it won't take any CLS, or it won't kind of have any relation with the class. Okay. The only relation it has is this is present inside this class, nothing else. Okay. It won't be able to do any sort of things here. If I need to do something here, let's say if I modify some R guy, it won't allow. The reason being this R guy is kind of not available. If I do here CLS, even this won't be available. It won't allow us to do. Okay. If I use the CLS here, let's see what happens now. Okay. Let me remove this. Now I'm making call to my static method again. Okay. So I think this is kind of, even though we can pass this, we are not supposed to. The reason being, we are kind of clearly aware of the method which needs to be static in the class. Okay. So in this case, we can kind of let me try. Even I haven't tried this out. Let me try to guy here. Okay. reason being, the CLS will make it a class method. Let me try to do this. Okay, it's not my class dot chatting method with missing one required positional argument CLS. Okay, so the reason being, even though I have given this CLS here, this is kind of used for only class method. Okay, if I am using this CLS, I need to decorate this method with this decorator, which is class method. Only then it will allow me to perform this activity. Okay, even I haven't tried this out, and this is how it turns. Okay, so whenever we are using class here, CLS, this indicates class method. Okay, but we need to use this class method decorator for sure. Only then it will try to convert it to this. Okay, now I have did same thing in both case, but here I don't have my class method decorator. And when I try to do this, it just throws error saying that missing one required positional argument CLS. Even though I have passed the CLS here, I'm kind of not decorating it using class method. I'm not declaring it as a class method. Okay, so now let me try out one more thing. I have this my class dot org is equal to okay, this is my what I am trying to do here. I have this my class object, and within this my class I have this org, right, which is my class variable, right? I'm trying to modify my class variable using this my class. Okay, now I have this C1, and C1 dot method will give me this C1 dot method will give me this what do you say, instance method called. Okay, and C1 dot static method. Now if I see my class dot org, let me check what happens here. Okay, you can see. Okay, this is kind of modifying the my class dot org as ROM. Okay, ideally it's not supposed to do this here. Okay, let me check what's happening. This is my C1. Let me print argay here. C1 dot argay now is okay. Yeah, yeah, I got the clarity now. So let me do this here. Okay, C1 dot argay dot argay, and I'm calling this C1 dot static method, and I'm just trying to call the C1 dot argay again here. Okay. Now it became wrong. The reason being I have called it as C1 dot argay, and it should also give, it is also giving us RAM. Okay. Mhm. Okay, ideally, this static method won't be able to modify this class state. Okay, as per definition, but somehow it's doing. So just allow me in our next session. I'll try to check why it's happening, and I'll bring in the what you say inference behind this. Okay, why it's happening, the reason behind that, so that even because even I am not expecting this to happen here. Okay, as per my understanding, this shouldn't happen. The reason being the static method is kind of static. Okay, this don't it won't be able to perform any changes to the class or instance. Okay, this is just present as a utility method. We can perform some utility task, and this is kind of like this is not depend on any of the other class methods or any class variables. Okay, class or instance variables. So let me check why it's happening, and you can have kind of just remember me. Okay, when we take tomorrow's class, just remember me that we are we need to find the reason why it's happening here. Okay, ideally it's not supposed to happen. So I think there might be some sort of what do you say internal misunderstanding. So let me check on that and we'll clarify. Okay. So with this, I'm ending today's session. Okay, so we'll be covering next things in tomorrow's class. So let me go back to this, revisit the things which we have defined. So we have covered HKR method. You are clear with this, right? What happens here? And we have methods, normal methods, which will be methods here in the sense instance methods. Okay. The reason I have given class methods is since we are dealing with class, I need to define it as a indicate it as a methods which are inside class. Okay. The class methods indicates methods which are defined inside class. Okay. This doesn't indicate a class method decorator. Okay. And then we have getter and setter methods. Even after creating instance, we can make changes. We can update the class state. Okay. And then we have seen static or class level fields. These are nothing but class variables as well. Okay. These are kind of tagged to the class, not the instance. And this will be available across each and every instance. Okay. And then we have covered three methods: instance, class, and static method. Just try to revisit them as much as possible. The reason being, even though I have understanding of this, when I actually execute it, it's kind of giving me different result. So this is sort of confusion which will arise in this instance class and static methods. Okay, just revisit them, and if you have any sort of doubts, or if you currently I have came up with this one doubt that ideally static method shouldn't be doing this thing, but it's doing this thing. Why it's doing? So it's not against the concepts or principles using which they have created the static methods. There might be some underlying cause which I haven't covered it. Okay, I'll just try to get more what you say in-depth reason why it's happening, and I'll try to present it like why it's happening and how it is behaving in that case. Okay. So now we have this instance method which are tagged to instances, and these can modify the class state as well using this self.class. And then we have class methods which are tagged to the class itself, and this won't be able to make any changes to the instances. The reason being we don't have any self keyword, and it's not tagged to the instance, but it's tagged to the class. We can make changes as a whole on the class itself. Okay. And then we have static method which is kind of it won't take any self or class parameters, and it won't be able to modify the instance or class state. Okay, this is the statement which is contradicting my output. So I'll try to get more on this. Okay, I'll try to understand why it's happening and what exactly this line means here. Okay, and I'll try to present it to you tomorrow. And then this is kind of used for any general utility methods. Okay, it won't we don't need any sort of inputs or any sort of things there. Let's say we have some timer function which will make which will kind of use it for timing or execution time. So we can use that timer utility function within our class, but it won't take any sort of inputs. Okay, we'll just take the timer module and it will try to calculate the current time present like happening. So we'll be using static methods for utility. The only relation between static method and class is it is present inside the class. It won't have any other access or any other this thing privileges inside the class. Okay. So these are the three methods available. So I'll be sharing this slide deck as well and just try to revisit them. Okay, again I am repeating. This is kind of more confusing. Okay, these classes and objects are very easy to understand. Matlab, it's kind of very easy when we look at very first instance at very first glance. This will be kind of very easy to understand. Okay, this is it. But when you actually try to implement it, will be kind of very difficult. You won't be able to understand things properly. Okay, it's kind of becomes extremely difficult when we try to access this. Screen share out there. Okay, I think this is it for today. So it's kind of I'll be we'll be covering next things. Okay, we'll be we are left with this inner class. This is similar to our inner functions or inner conditionals. Okay, it have just class inside a class, and then from tomorrow, like we'll be starting with the principles, encapsulation, and other stuff. Okay.